Hi, I am Eugene. This video is a short summary of JUICE and ready to predict private information in deep cooperative reinforcement learning. In human-robot collaboration setting, each agent often has access to private information that is unavailable to others. Examples include task preferences, objectives, and beliefs. Here, we focus on a human-robot dyadic scenario where the human has private information but is unable to directly convey it to the robot. We present Q-network with private information and cooperation, also known as Q-PICo, a method for training robots that can interactively assist humans with private information. We also contribute JUICE, an environment inspired by the popular video game Overcooked, to test Q-PICo and other related methods for human-robot collaboration. The following diagram shows the Q-PICo architecture during training phase. The red Q network represents 5, the human surrogate, and the green network represents Lambda, the robot. The blue private information network predicts data using the human actions. We interleave the training of Q networks and the private information network, fixing one while we optimize the other for a fixed number of iterations. In contrast to the existing approach, we explicitly model private information prediction, leading to a more interpretable network architecture. For each agent I, we train the Q network by minimizing the Bellman error. To train the private information network, we treat each as a regression problem and minimize the square error between the predicted and true private information. We use JUICE to evaluate the Q-PICo framework. I will briefly describe our experiment setup. On every step, the agents can take one of 6 actions: do nothing, interact with the object, move up, down, left, or right. The customer, which is depicted as the chicken on the right, wants apple in this case, and the human and robot are supposed to bring apples to it. We make 3 observations. First, the agents often achieve the maximum possible reward of 2, suggesting that the Q-PICo framework is effective at training pairs of agents to exhibit collaborative behavior. Second, the robot always takes the corresponding fruit only after a human. In other words, the robot waits for informative actions to adapt its subsequent behavior. Third, the performance of the agent improved as the mean square error loss incurred by the private information network decreased. Here is an animation of the experiment when the true private information defaults. The left shows the trajectory when data star is apple, and the right shows the trajectory when it's orange. Moving forward, we hope to scale our technique towards more complex scenarios. For more information, please look at our paper. Thank you.